Welcome back, Year 5. Today's lesson is our final lesson dealing with angles. We'll be calculating lengths and angles in shapes. Our learning intention is to reason about shapes to calculate missing angles and lengths. This lesson can be quite tricky just because you really have to think deeply about things. So don't get overwhelmed. We're going to take things one step at a time, and I'm going to show you my thought process as I would deal with problems like these, and then you can try it yourself with the independent work. If there is someone at home who you can discuss today's learning with, I strongly recommend that you sit down with them for this lesson. First of all, let's build some background. Since we're going to be reasoning about shapes, there's two facts that we need to keep in mind. The first one is about shapes that are called quadrilaterals. That's just a really fancy word for a shape with four sides. So quadrilateral is just a shape with four sides. Now, this is the fact. Angles in a quadrilateral add up to 360 degrees. So no matter what that four-sided shape looks like, the angles will always add up to 360. Square, rectangle, rhombus, diamond, kite, all of those four-sided shapes, their angles add up to 360 degrees. Here's a four-sided shape. All of the angles are labeled except for one, x. I want you to use your knowledge that all the angles in a quadrilateral add up to 360 degrees to work out what that missing angle is. Pause the video, and when you come back, I'm going to tell you what the answer is. The missing angle is 105 degrees. How do we know? Well, the angles that we do know, 100 degrees, 95 degrees, and 60 degrees, that all adds up to 255 degrees. And we know the total of all the angles will be 360. So if we do 360 and take away all the angles that we already know the measurements of, so that's 360 minus 255, we're left with 105 degrees. So angle X is 105 degrees. Again, keep in mind the most important thing here is that the angles in a quadrilateral add up to 360 degrees. Let's look at another shape. So here's our second fact. Angles in a triangle, or a three-sided shape, add up to 180 degrees. Doesn't matter what the triangle looks like. It could be short, it could be tall and skinny, it doesn't matter. The angles will always add up to 180 degrees. With that in mind, what is the measurement of angle X? We know that the other two measure 70 degrees and 60 degrees. Take a moment and work it out. When you come back, I'll tell you the answer. Well, X measures 50 degrees. How do we know? Well, we know the total must be 180. So if we take away 60 and take away 70, we just need to see what's left to figure out what X is. 60 and 70 added up make 130. So I just need to do 180 minus 130 to see what's left, and that leaves me with 50 degrees. Again, the most important takeaway from this slide is that angles in a triangle add up to 180 degrees. Now that we've built some background knowledge, let's take a look at the Discover page in the textbook. Here we see that Lee is in class, and it looks like he is making a parallelogram with some paper. On the board, we see a diagram of the steps that he should be following. He starts with two squares, a red square and a yellow square, but they have the same measurements. All their sides measure 10 centimeters. The next step is to cut those squares in half diagonally. Notice how when he cuts them in half diagonally, they get turned into what shape? Triangles. Specifically, right-angled triangles. You notice how the bottom corner, or the top corner, of each of those triangles is a right angle. You can fit a little square in the corner. Then it shows below how he can assemble those triangles to create a parallelogram. So he just has to fit them together a certain way. Let's see what we're asked about this particular scenario. 1A says, what are the interior angles of the parallelogram? Now you probably saw interior angles and went, what? It's not that complicated. It just means the angles on the inside of the shape. So if we look at the shape, the parallelogram, specifically the one that's all yellow and has B along the side and A along the bottom, we can start thinking about what those angles measure. Now we could whip out a protractor and actually measure them. Or we could reason on how the two squares from the beginning were split up into triangles to form this parallelogram. Let's try that. Let's go back to the squares and start thinking about the angles in those squares. Now, in a square or a rectangle, all of the angles on the inside, the interior angles, measure 90 degrees. 4 90-degree angles adds up to 360. So that makes sense with what we learned earlier. A quadrilateral or a four-sided shape, all the angles add up to 360. When he cut those squares in half diagonally, notice that the angle at the bottom left and at the top right remain 90-degree angles. But he split the other two 90-degree angles in half. What happens when you split a 90-degree angle, or the number 90, in half? Well, if you take 90 and divide it by 2, you get 45. So that means these triangles, those other interior angles other than the right angles, are 45-degree angles. Now, does that work? Well, let's think. Remember, triangles, all the inner angles must add up to 180. That's for any three-sided shape or any triangle. 90 plus 45 plus 45. Does that add up to 180? Yes, it does. So that makes sense. So now we understand all the angles in those triangles. Let's now keep those measurements in mind as we look at the parallelogram. All right, look at how that red triangle was moved down for the corner of the parallelogram. Well, the angle that I've now highlighted on the screen, we already know what that measures because we figured it out earlier. We calculated it. It's a 45-degree angle. And the angle on the opposite side of the parallelogram, the other kind of pointy one, it's the same thing. It's a 45-degree angle because it's the corner angle of one of those yellow triangles we worked out earlier. What about the other two corners, the ones that I have circled now? Well, we can see that in those corners, there's a right angle along with a 45-degree angle. They've been pushed together. So if we add those up, we can find what that angle measures. And that's 135 degrees. The angle on the opposite side is the exact same thing. It would also be 135 degrees because it's that 90-degree angle and that 45-degree angle. But does this work? Let's see. 45, 45, 135, and 135. Does that add up to 360? Because remember, all four-sided shapes, their interior angles, those inside angles, must add up to 360. Stack those numbers and check. Does it add up? Once you finish stacking, you would have realized, yes, it does. It adds up to 360. Now, I've included the share page as well. And the A part on the share page explains everything we just went through. So I'd like for you to pause here and just have a read through that just to reinforce what we just went over. Now let's take a look at the B question. It says, Lee thinks length A must be 20 centimeters and length B must be 10 centimeters. Is he correct? Well, let's go back to the shapes that were used to create the parallelogram. Remember, he started with those two squares, and all the sides of those squares measured 10 centimeters. When he cut the squares in half diagonally, that didn't change two sides of it. Two of the sides still measured 10 centimeters. So when he put the shapes together, as we can see down below, when he stuck those red and yellow triangles together, what happened? The sides of two red triangles formed the top of the parallelogram, and each of those sides measured 10 centimeters. So that means the top measures 10 plus 10, or 20. What about the bottom? Well, that's made up of the sides of two of the yellow triangles, and those sides we know measure 10 centimeters because they were 10 centimeters when it was a square. That never changed. So again, it's 10 plus 10, making 20. So that means Lee is correct when he says that length A must measure 10 centimeters. But what about length B? Length B is the diagonal side of that triangle. We don't know that length because when he cut the square in half diagonally, he created a new length that cuts down the middle. Now, unfortunately, I'm not there with you. I can't whip out my ruler and prove to you that this does not measure 10 centimeters. So have a look at the share side of the page under B. Read through, and they're going to explain there as well that while he is right about length A, he's not correct about length B. Now let's take a look at one of the questions from the Think Together page. This is question 2. It says, work out the length and width of shape B. What they've done here is they've used shape A and turned it into shape B. Do you notice that red arrow in between? That just means they broke apart the bits of shape A and then changed around their location to create shape B. In order to answer this question, what we need to do is understand shape A as well as we possibly can. All right, so at the top of shape A, there are two trapezoids, 1 and 2. They are identical. That means they're exactly the same. Notice that the top of those trapezoids together measures 80 millimeters. If they're identical, we could figure out what the top of one of those trapezoids measures by cutting 80 in half. So that would mean that the top of each trapezoid measures 40 millimeters. I'm going to go ahead and label that. All right, what about the length going down the middle of those two trapezoids? Well, I notice that those two trapezoids together on top are identical to the big trapezoid at the bottom. Let's call that trapezoid 3. That means that they have the same height. So notice along this side, it says that the total height of all three trapezoids together is 90 millimeters. But if I cut that in half, I can find the height of the top half of the shape separately from the bottom half. So what's 90 when I cut it in half? 45. So that means that length down the middle is 45 millimeters. I'm going to label that as well. Something else that they've told us is that the width from side to side of this full shape, shape A, is 120 millimeters. That means that the line running through the middle of that shape measures 120. But it also tells me that the bottom of each of the small trapezoids, trapezoid 1 and trapezoid 2, is half of 120 because those two shapes are exactly the same. So if I cut 120 in half, I get 60. That means the bottom of each of shapes 1 and 2 in shape A is 60 millimeters. Let's take all of that information and transfer it to shape B. So first of all, I can see the two small trapezoids in shape B. They're at the ends. And I remember the tops of those trapezoids measure 40 millimeters. So let me label that. I also remember that the side, or that length going down the middle of those two small trapezoids, was 45 millimeters. That means the sides of those two small trapezoids in shape B also measure 45. So I'll label that on the sides. Another thing I had learned about the two small trapezoids is that their bottom measured 60 millimeters. So I'll go ahead and put that in as well. What did I know about the bigger trapezoid from shape A? Well, I know that the length through the middle, that longest side of it, measured 120, so I can label that. I also know that that bigger trapezoid has the same measurement as the two smaller ones put together. So that means the top of that trapezoid, or rather the bottom of it, the smaller side, measures 80 millimeters, so I can label that as well. Now that I have all this information, I can figure out the length and the width of this shape. The length running down the side is simply 45 millimeters. For the width, I just need to do a little bit of addition. And I can pick which side I want to add. They're going to add up to the same thing because my shape is a rectangle. So I'm going to add up the bottom values. So I have 60 plus 80 plus 60. What does that add up to? 200. So the width is 200 millimeters. So as you can see, with problems where you have to try and work out the angles or the lengths of shapes, it just takes a bit of reasoning. You have to think about it and look at it and break things apart. But it's not particularly hard. Now we're going to go backwards a little bit and look at the angles. So this is Think Together question 1. It says, Lee fits together the 4 triangles in different ways. What angles can you work out without measuring? So that means they don't want us to use a protractor. Well, for this one, what's important to keep in mind is that these triangles are supposed to be the same triangles that he used on the Discover page. So that means they have a right angle and they have 2 45-degree angles. With that in mind, we can label all of the angles in the first colored image, the blue and yellow diagram. Once we've done that, it's actually quite simple to work out what all those angles measure on the other diagram, P, U, T, Q, R, and S. I want you to take a moment and see if you can work out what all of those angles measure by transferring from the first diagram to the second. For some of the angles, specifically angle U, Q, R, and S, you're going to have to do some addition. Pause the video and work it out. All right. Well, angles P and T should have been giveaways. Those angles are just 45 degrees. It transferred right over from the first diagram. What about angle Q? Well, for that one, you would have had to do 90 plus 45. What does that add up to? 135. You would have gotten the same answer for S because it's the same angles added up, 90 and 45. What about R? Well, for R, you have two 45-degree angles put together. So that would create a 90-degree angle. And finally, U. For this one, you had 4 different angles to add together. A 90-degree angle, a 45-degree angle, another 45-degree angle, and another 90-degree angle. What does that add up to? 270 degrees. So, by transferring what you knew about the shapes that made up the first diagram, you were able to work out all of the angles in the second diagram, even though they didn't have all those lines splitting it up for you. For your independent work, you're going to need to transfer these skills of using what you know to figure out what you don't know. And here is your independent work. It's taken from pages 72, 73, and 74. Please remember what I said earlier. If there is someone at home who can sit with you for this assignment, that would probably be very helpful. Also, remember that the angles in a triangle add up to 180 degrees, but the angles in a quadrilateral add up to 360 degrees. When you're all done, make sure you take a picture of your work and email it to me. As always, stay safe and I'll see you soon.